this question is saying the angular speed of a flywheel, it's a uniform angular acceleration. So the angular speed is changing from 1200 RPM revolution per minute to 3120 RPMs in 16 seconds. So very straightforward question here we have, right? The angular acceleration alpha is given by the final angular speed minus the initial angular speed upon the time interval, the time it takes for that change to happen, okay? So here we have omega f given. But here one thing we have to notice here, that omega is, the unit is radians per second, right? Radians per second omega. Here the omega is given in form of RPM, revolution per minute. So this one will have to change in radians per second, okay? So 1200 RPM is 1200 revolutions in 1 minute. So that is equivalent to 1200 revolutions. That means 1200 times 2 pi, this much angle it rotates in 1 minute. So if I divide by 60 seconds, in 60 seconds it rotates 1200 into 2 pi radians. So I divide by 60 seconds to get how much it rotates in 1 second. Okay. So basically I have to multiply the RPM with this thing, 2 pi upon 60 here, okay? Similarly, this 3120 RPM, I can say is 3120 times 2 pi into 60. This much radians per second, the omega is, okay? And initial was this much radians per second, okay? So I use the formula here, omega final is 3120 into 2 pi upon 60 minus initial was 1200 into 2 pi upon 60, and the time it took was 16 seconds to change the angular velocity from initial to final. Okay, so this, if I simplify, this is going to be 2 pi upon 60 into 16 times 3120 minus 1200. That will come out to be 2 pi times 1920 here, and then 60 into 16. Okay, 16, this is 60, so this is 12 times, and this is 2 times. Okay, so ultimately I am getting 2 pi into 2, that is 4 pi. Okay, so 4 pi radians per second square is the angular acceleration. Okay, 4 pi radians per second square is the angular acceleration. So the answer number 2, the option number 2 here, 4 pi becomes the answer for this question. Okay, straightforward formula based question, right? Thank you.